This is not curved. I know that sounds ridiculous, but it isn't just the tracks. The entire world is perfectly straight. To understand why, we need to start with what Subway Surfers has been pretending to be being endless. Everything you interact with in the game fits inside this surprisingly small area because the city isn't actually getting bigger. It's the same handful of tiles being recycled over and over again. And Jake, he hardly moves at all. Instead, the entire world is moving towards him, like a treadmill. Keeping the player in one place makes the game far easier to manage. Objects can be recycled instead of recreated, and the game never has to deal with massive world coordinates that come with running really long distances, avoiding floating point precision issues. Which brings us back to the curves. You see, when your world is entirely built from procedurally spawned tiles, a perfectly straight road becomes a problem. The farther you can see, the easier it is to spot new tiles popping in. Think of Minecraft loading new chunks. It's not exactly a pretty sight, is it? To hide this, developers use a combination of fog and a curved horizon. Just like how the crest of a hill hides the road ahead, Subway Surface hides what is beyond the horizon, giving new tiles just enough time to appear without you noticing. But there's a problem. Every object in the world has to follow the same curvature. Rigging every train, barrier, coin, and decoration would be a nightmare. So, how do games bend an entire world at once? The answer lies in how games deform geometry. There are two common approaches. The first uses armatures, bones, and rigging to physically bend a mesh. This is perfect for characters, where every limb needs precise control. The second skips the bones entirely and deforms the vertices directly inside a shader. Think of grass and water animations. For something built from hundreds of independent objects, the shader approach is perfect. Instead of modeling curved roads, the developers build everything perfectly straight. They then bend the entire world at render time, which means the gameplay stays perfectly straight even though the world you see isn't. At least for Subway Surfers, that is. You see, other endless runners have a much harder problem. Temple Run also recycles its world, but it has an extra challenge: actual 90-degree turns. If the player isn't really traveling to the world, how is that turn even possible? The trick is surprisingly simple. When you swipe, the player and the camera rotate 90 degrees. Then, the game changes the direction the world moves. Nothing actually bends, and nothing needs to rotate around the player. The world simply starts scrolling in a new direction, creating the illusion that you turned a corner. There's still one thing that doesn't quite add up. If the entire world is moving towards the player, how can trains move even faster? It's not just that the trains have a different velocity, it's that they don't have to move with the rest of the world. Think of the scrolling world as one giant stage. The tracks, the bridges, the parked trains, they're all spawned as part of that stage. But gameplay objects are different. Anything that needs its own behavior, like moving trains, coins, power-ups, or obstacles, are independent of that stage. This allows the developer to fine-tune each object. A train can race towards you, a coin can spin in place, and an obstacle can animate, all without changing the fact that the player is standing still. So the next time you play Subway Surfers, you won't just see an endless runner. You'll see a straight world, a player who barely moves, and a carefully crafted illusion designed to make you believe otherwise. And if you're a developer who wants to experiment with these kinds of world-bending effects, I've built an Unreal Engine asset that lets you do exactly that. You can find it linked in the description below. If you enjoy this video, make sure to leave a like and consider subscribing. With that said, I'll see you in the next one.